Okay, babies, we are going to look at example 11, which this is just reading box plots, not building them or anything. So if you will look at what we have here, we have box plots representing calorie intake for Chick-fil-A menu items separated by breakfast or lunch and dinner. Okay, so one thing about a box plot, you'll notice these are always going to be labeled out to the side, which one's which. And so when you build your own box plots on the next example, you need to pay attention to that. If they're not labeled, it's not right. And then of course the x-axis is labeled with what we're measuring down here, which would be calories. Okay, so part A, even though both of these plots are relatively symmetric, why would I talk about the medians when I'm comparing the centers for the two calorie distributions? Kids, the obvious answer is the right one. Here's the median for lunch dinner. Here's the median for breakfast. We are going to talk about the medians because they are visible. The medians are visible. A visible measure of center is always preferable over one that you have to estimate. So the medians are visible and therefore it is appropriate to talk about them, even though they're symmetric. All right, remember, statistics is gray area math. There's never just do it this way every time. It's very rarely. Okay, so which menu, breakfast or lunch and dinner, would you say has more calories in general? Justify your answer with at least two pieces of evidence from the graph. Okay, so if you will look at this, I want you to notice that the breakfast items, their lowest calorie value is higher than the lowest calorie value for lunch and dinner. Their highest value is higher than the maximum value for lunch and dinner, and their median for breakfast is higher than the median for lunch and dinner. So basically I gave you three things, but you only have to mention two. So breakfast has both a higher maximum and a higher median calorie count than lunch, dinner. Okay, and remember this is in general because could somebody come in and order something off the breakfast menu right here with that many calories, and then later in the day they could order something up here that's higher in lunch and dinner? Yes, but in general, based on the graphs, that's how we're answering the question. All right, part C, we are estimating the interquartile range for both menus. Show your work. Okay, so for breakfast, I've got my IQR, of course, is equal to Q3 minus Q1. So if you will look at the breakfast, Q3 is right here, so 550. Q1 is right here. That's almost perfectly in the middle between 300 and 350. So that's going to be 550 minus 325. And that's going to give me 225. Check my math. Did I get it right? Okay. And then we've got our lunch dinner here. That IQR is going to be Q3, which is right here. That's about 460, I'd say. And then this Q1 here is probably about 280. And these are estimates because, I'm not measuring it or anything. I'm just eyeballing it. What did I just say? 460, out of control. Can't take me anywhere. So 460 minus 280 is going to give me 180. So I've shown my work. So there you go. That's perfect. All right, part D, focus on the lunch dinner menu box plot. The piece from the minimum to Q1. Okay, so that's this right here. I'm going to erase some of this so we can see it. So that is the minimum to Q1 right there. about 140 to 280 is longer than the piece from Q1 to the median. Okay, so that is right here. So this, of course, is longer than this piece. Does that mean there is more data in the first interval? Yes or no, and explain your reasoning. Well, as you may remember from the Boxplot initial video that I gave you, remember that the way a box plot is split up, we have 25% of our data here, 25% here, 25% here, and 25% here. So it's not that there's more data, so I'm going to write no. There isn't more data. The data is just, you remember, more spread out. That's what that means, okay? That's what that length in that piece means. Okay, so list two things about the box plots that are similar to one another. Okay, so this is something that a lot of students tend to struggle with, so pay attention. All right, if you'll notice here, I know that there's some overlap, so it's a little difficult to understand this, but if you'll notice this box plot is almost the same length as this box plot. So their length, even though they overlap and they're not right lined up with one another, that doesn't mean that their lengths are really that much different. So two things about the box plots that are similar to one another. The overall lengths are about the same, and they're not perfect, it's not identical, but they're about the same. And what's the other thing? Neither one of them have any outliers. Awesome. So exciting. It's so exciting I had to put an exclamation point. Magical, magical. Okay, example 11 is finito.